Today I'm going to be teaching you about a particular mathematical property that I discovered while messing around with a Rubik's Cube. Well, actually a Moyu, because, I am civilized. Most cubers know that if you continuously repeat the same set of moves over and over again, you will eventually return to where you started. In this particular case, it's going to take me 6 repeated applications of the permutation to return to a solved position. But what is the math behind this? The answer lies in the way the pieces fit together. 1 core, 12 edges which can be arranged in 2 ways, and 8 corners which can be arranged in 3. And all this has to be divided by 2. 43 quintillion, 252 quadrillion, 3 trillion, 274 billion, 489 million, 856,000, all of which happens to be less than infinity. 33 quintillion cases are a lot. Let's start with something simpler. Let's consider a list of 6 objects. Let us assume, for example, that the first one moves over to number 4. 4 had to move somewhere now, so let's say 6. But the same thing applies for 6, except this time it can't move over to 4 because 1's already moved to 4. So it's got to choose a different place. For example, 5. Rinse and repeat, and eventually you'll find you run out of places in which to move. No matter which of the 6 positions you initially start in, you eventually move through all 6 other positions and return to the beginning. But what if it doesn't move through every single other position? For example, keep an eye on the red one. It's going to move through every other position, then loop back through the beginning. And at the same time, the green ones are going to loop every 4. So the red ones loop every 5, while the green ones loop every 4. So in total, they must loop by the least common multiple of 5 and 4, which happens to be 20. Back to the cube. In our original permutation, 2 of the corners are going to switch positions and flip once, which is going to permute every 6 times. And 2 of the back ones are going to do the same thing. On top of this, 3 of the edges are also going to switch around each other. This means that in total, we've got the least common multiple of 6, 6, and 3, which happens to be 6. And if you count them right here, you'll notice that the permutation is indeed applied 6 times.